very last thing is compound inequalities. And these are actually not very complicated. They're just like what we were just doing. The only thing is you have multiple sides. So compound inequalities, we graphed one earlier where it's like x is between two numbers. Same thing. We've got three sides, but this time we're going to be left with, something like this. We still want to get x alone, but x is going to be in the middle this time. Okay, so this is our goal. And you transform exactly the same. So, but this time you have more sides. So if I want to get x by itself, I need to get rid of this 2, right? But that means I need to do it to this side, and I need to do it to this side, right? Because I have 3 sides to my equation now. Okay. And again, now I'm going to divide all the sides by 5. If it was -5, right, what would I do? I would flip all of the signs, right? But it's positive, so I don't have to flip them. And we can just keep this in fraction form. So x is greater than -4/5, and x is less than 3. So if you want to graph that, 1, 2, 3, open circle, right? Here's -1, -4/5 is right here, and it's an open circle. Might be easier to do it above. And then you shade in between, right? X is between these two numbers. Hopefully that's not like too confusing. Okay, I want to get rid of the 12, so I get -2x is less than, it's less than, it's greater than 6. Okay, I'm going to divide both sides by -2. This is where I'm dividing by a negative, right? So that means my signs are all going to flip. Oops, and I didn't flip it. So greater than -6 and -3. And if it helps, you can do, it's easier to visualize that way if you always put the bigger number on the right, the smaller number. 1, 2, 3, 4, 5, 6. So we've got -3, -6. It is less than -3, greater than -6. But yeah, just like solving equations, except now we have 3 sides to transform. And then you end up with a little range of right answers, right? As opposed to it just goes on for infinity in one direction or the other. This is a between, right? Between two numbers. Another one you might see is an or one. So when you have this, this is kind of like an and. So x is less than 3 and x is greater than -6. Okay, you could think of this as like an and. You might see something like or okay, so we'll solve these two and then graph them on the same number line. Okay, this is the same problem. We're saying x either follows these rules or it follows these rules. Okay, so let's just solve. And you'll see what I mean when I graph it. 3. Okay, so that's this one. And then I'm going to get rid of 5. I'm dividing by a negative, right? So my sign has to flip. Okay, so this right here is our right answer. So whenever you have an or, it's going to be the opposite of between. 1, 2, 3, 4, 5, 6, 7. Oh my god. 1, 2, 3, 4, 5. Okay. So x is less than 5, negative 5. Open circle, right? Can't be 5. We're going to go this way. Or greater than or equal to, so I can have a closed circle, 7. So when you have something like this, it's just saying as long as x either fulfills this one or this one, it doesn't have to do both at the same time. These are all the range of right answers. So now it's it's opposite from between, right? It's kind of like the outer side. So not between negative 5 and 7, but greater than 7, less than negative 5. And if you pick a number here, it'll only work for this expression, this inequality, right? And it won't work for the other, but that's okay because this is an or problem. It doesn't have to fulfill both at the same time. It has to just fulfill either this one or this one. Okay. And so, yeah, your answer would be this. Okay, so that's everything with inequalities.